I started this question by drawing a force diagram. We have a particle on a slope and we don't know the mass. It's going to be a normal reaction and it's accelerating down the plane. It's a smooth slope, so there's no friction. So that's your kind of force diagram. It turns out that the forces here are all constant, so there's going to be constant acceleration. So in fact, SUVAT will get us started with part 1. So SUVAT, the distance is 6.4 for your displacement. U is what we're trying to find. V is 5 is given. The acceleration we don't know, it's on a slope, so you can't say it's 9.8, and T is 1.6. So we have two unknowns here, and by choosing suitable SUVAT equations to exclude either letter, we can solve to find U and A. Perhaps the one we could pick the one with no A in and solve to find U. Now the equation with no A in is S equals U plus V over 2, that's the average velocity, times time. And if you substitute in, you can solve that. So U plus 5 over 2 times 1.6. Solve the resulting equation and you'll get that U is equal to 3 meters per second. Then the other equation that will get us A here, well, there's a choice. We could use, for example, V equals U plus AT. So if you use that, we've got 5 equals 3 plus 1.6A. Solving that gives you A is 1.25 meters per second squared. So that's the answer for part 1. To do part 2, you need to now use your force diagram. This becomes important. What you'd want to do here is resolve parallel to the slope to try to find something about use this acceleration information we have down here to help you find the angle involved. So resolving parallel to the slope, if you were to do that now, using F equals ma, so you have to remember it's not in equilibrium. We've got mg, component of the weight acts down the slope. Mg sine theta is the only force acting down the slope, and that's equal to ma. Now A is what you just worked out, 1.25. The m's we don't know, but they cancel, so we end up with sine theta is equal to 1.25 over g. So if you do inverse sine, you'll get the angle you require, which is you get the angle 7.328, but that's not the angle we're asked for because it wants the angle to the vertical. Now that's actually this one here, which is going to be 90 minus this angle. So the required angle is 90 minus theta, which actually comes out as 82.7 degrees to 3SF. So there's a moral there to read the question. Whenever you think you've finished, read it. So a lot of people would lose that mark there at the end.